Welcome everyone. I'm quite surprised that you show up for a presentation with such a boring title. Let's see if you can take something valuable from it. I want to start with this. Can you raise your hands who is on the developer side, develops operations? Okay. Can I assume that the rest are security guys? Security guys? Okay, so and can somebody that didn't raise his or her hand say what are they into? Architecture? QA. Okay. Welcome. All right, so that is a bit of the situation we have now, and it's very sad. So I have a background in cybersecurity. Now I'm doing a bit of the whole technology side, including security. And I have worked also close with teams that still have this on the security side. And well, security professionals are always not happy of how developers work. Developers are not always happy how security guys work. But I don't think this is a new problem. But first of all, I wanna give you a couple of reasons why to listen to me. So I am Santiago Aragon. I'm not German, as you can see from my name. I was born in Mexico, and 10 years ago I moved to Europe. I actually live in Germany. I study in University of Saarland, then in Darmstadt. Then I went to the Netherlands, Poland, Sweden. I did a couple of things. And very quickly I realized I like the entrepreneurial world. I had a small bump with ING, that is a big bank in the Netherlands, but that actually brought me to what I'm doing now, that is XLINQ. In the free time, I like to run, CrossFit, read. I'm trying to start a podcast, it's not really successful yet. And I advise young bachelor students on how to jump to the professional life. And, sorry? And yeah, I like to cook. But the red line in all these small logos and activities is I love the intersection between people, technology, and complexity. And that is actually what brought me to security. That's what brought me to technology later on. And that's what brought me there. I am a technology lead for XLINQ, a company that you have never heard about it. I hope that you hear about it in the future, and I will tell you later what we do. But let's remind where were we? Actually, we also, for the ones that are old enough here, we kind of had the same situation with development and operations. First, we thought you guys in this basement are gonna develop, and then we throw over the fence whatever we get, and then a guys on another room will try to run it. Right? We know that that was not the best choice, and we might have this with the upcoming cloud usage, right? So now we can have sec DevOps or whatever trend that you want, and now there is another discipline, the FinOps, for whatever that means. But that basically implies there is another dimension that we didn't took into account on the development process that somebody needs to fix. All right, so what is the agenda? I think that there is a fundamental problem, and it comes from the division of the what and the how when we develop software. I will focus on security this time, and I want to show you how at least XLINQ did that in the fundamental way, in the process perspective. So how did we shift left security, and how did that help us to get speed? And somewhere in this talk, I will make the case of, okay, security is actually nothing else than software, and what does that imply when we start looking at security controls as actually software components. All right. So everyone has an iceberg metaphor, so I thought that was also a good idea. The complexity of software development. Normally, when any product manager or manager, CEO or whatever tells you, I need just this tiny bit of application. It's very simple. This is what I need. Should be done in a couple of months, right? And then, okay. The requirements are not always clear, but then we start diving into the lower part of the iceberg, and then we start realizing that there is a lot of non-functional requirements that if we want this application to be live, we need to honor, right? So how long should be available, how confidential the data should be, how scalable should it be, what kind of guarantees do we need for our application? Do we need integrity? Do we need timeliness? Do we need non-repudiation, right? Depending on which industry you are, these non-functionals might be more relevant for you or not. And then, I mean, you are all locked here. I think that there is engineering talent shortage. That is another complexity that we just need to add. But basically, the summary, that is how the functional requirements normally look. It's just a login page. How hard can it be? Let's call it the what. And then you have actually the real complexity, that is the non-functional side, and we're going to call it how, the how. All right, so you might be familiarized with this V model. That is a bit basically how Mr. Donald Firesmith represented how do we develop software and how do we test it, right? So you can think about the horizontal line as time, and then and the message of this model is the testing. Every time you go down takes shorter, right? So you can do quicker iterations, and that is basically what you would like to have at the end. So shorten the time between implementation and unit testing. That is the one that will have closer to the code side. And then when you go up, basically acceptance test and testing. But there is a very key difference. There is a validation from the user perspective, and then there is a verification that our requirements were properly implemented. So there is a clear definition between the what that we validate with end users and the how. How do you actually do it? And actually, so I thought we had this problem when we started XLINQ. We have the problem because our ambition was to generate applications at a faster pace inside the bank. I don't know if any of this is grammatically correct, but banks are extremely slow. Any big corporate is extremely slow, especially banks that are regulated. They have extremely high complexity on the handover side. They have a lot of teams. You need to get approvals, etc., etc., etc. And that is what XLINQ started. So basically, I was having a conversation with someone in the audience here. What we do is we generate code automatically. He didn't believe me until a couple of clarifications I did. This is not a talk about XLINQ. If you are interested, come to me. But basically, what we did is we split the what and the how. So we thought about the software process as a 3D printing, right? So what we cannot automate is what the requirements are. So that needs to come from someone. And then everything in the middle we did automate. So we defined high-level compilers that allows us to generate applications automatically. This is not relevant, just that is doable. That is the message. And I think the framework of thought that we use can be useful for a lot of people here. And is the basic separation between a division on the what and the how. The how can be shift left and automated. That requires an investment, of course, but you can always start thinking and start asking ahead, and that will make your development cheaper at the end. So how did we did it? We split this either. We put it around and we said we are going to start with the end. How? What are the non-functional requirements of the software, and how do we split them together as fast as possible? So risk, security, compliance, availability. We shift all the requirements left, right? And then we didn't start implementing anything until we know the full list of NFRs. So we did it with risk, with security, with changeability, and because this talk is about security, we will focus on that. So, what are the two main ideas that we use when designing all this automation? And the first one is building layer 8, and for all the ones that know the joke, it's basically the human layer. How do you embed security on your development team, right? Of course, can also be the user side, but here it's about your development. And I want to bring you back to here. So if you build a level 8, he should not be cleaning this beautiful rainbow. When you don't include level 8 in your development process, you get things like this, right? So basically, somebody tells the security guy, oh, by the way, the login should have been secure. You get a very nice tool. It doesn't really work. And we learned a couple of things because we did it also with developments and operations, right? At some point we thought, I develop it, you run it. So we have these beautiful silos. Then we discovered that it's not really optimal. So we moved to DevOps. We develop it, we run it. So the ownership from actually running the code, running the product, solving a business need is in the same team. Right? It's not necessarily in the same person, because I'm not advocating to have developers with ships with 5 legs, right? So I don't want a developer to know, to be a security expert, an operations expert, an architect, a cost expert, etc., etc., etc. It's about the ownership of the team. But in DevOps, we still have these kind of things, right? So I think that in this report, 86% or something of the data leaks are basically human errors. And when do we have human errors? Or when always, of course, right? We are the only ones that can make errors. But when does the chance is maximized? Is when there is handovers. When there is handovers of information, when there is context difference, when we have two different silos, right? Develops, operations, security. Yeah. Then Gardner and all these guys that need to sell a lot of stuff came with all these nice terms: SecDevOps, DevSecOps, blah blah blah. It doesn't really matter how you call it. It's the realization that security is a fundamental part of whatever digital solution you're doing, right? And the moment that you have a separate security team that is actually not giving direct advice to your development teams, that doesn't have a platform function, right? That like your CI/CD, etc., etc., you will always have this kind of silos that don't lead to the optimal solution. And this food for thought for you. I show you FinOps. Maybe there is a couple of other sections, a couple of other dimensions that we have not think about including in this development process or this development ownership that will benefit actually to be there. I don't know if someone had a nice surprise with their cloud invoice at some point. That's a good example why, for example, that should take also a place in a design document. So then we secure it, we develop, we run it. And then what happens when you understand security as your fundamental building block in your development team? You start having very nice vertical integrations of security, right? And I am very proud of some of the features up there, but basically because our development teams are super aware of security, because they challenge the security guys that sometimes it's me, sometimes it's a pen tester, because they are able to have these conversations that at the end up being very valid for them. You end up having very nice things like not only the awareness, but there is interesting security primitives that start popping up in your building blocks, right? we managed to have very performant lookups over encrypted data. Homomorphic encryption is not something that happens in the industry at performant levels, but we still managed to have encrypted data and secure lookups of that and be able to serve 20,000 transactions per second. So layer 8, we said that is the outer layer of that, and you know that security is like an onion. So the second principle that we follow is Defenceindepth. The moment that you start understanding security as just another piece of your code, you might stumble upon problems that you stumble up with normal code. There is bugs, there is misconfigurations, there is things that just sometimes do not work, right? And Defenceindepth basically help you to address this by thinking in your OC layer or TCP/IP layer, and helping you to map which controls do you have at which level, right? And if you only have one in one of the layers, well, you have a weak point, right? And it's for you to think how likely is this weak point gonna hold, or in which situation this weak point might fail. And maybe if you want to minimize the risk because you know that your provider of the, for example, perimeter security is not the best, maybe it's a good idea to invest in the lower layers to don't have a single point of failure. And we know what is the weakest link, the human, layer 8. But in a chain, the weakest link, the security of the chain, sorry, will be always as secure as the weakest link. And then Defenceindepth we use to think what is the probability per layer that it fails, right? So basically, without mentioning a cloud provider, we hire this denial of service protection, etc. We knew that we were denial of service proof. We go with an external auditor, go and test our denial of service. What happens? The denial of service didn't work because the machine learning algorithm behind failed to recognize that from one single IP there were millions of packages coming. And then because we have this Defenceindepth principle, we thought, okay, we never tested our DDoS, but we know that there is a certain probability that this will fail. So in which other layer can we afford to have some kind of protection, right? So basically what we did is at network level, we created some automation that help us in case the denial of service layer fails or do not perform as it should be. At least we are not gonna be down for 24 hours. We have a way to serve the most valuable users, so to say. I'm sure everybody knows the Chinese wall, and I'm not sure if everybody is also aware how bad idea was to protect actually China in some of the areas. So there is some of the areas of the Chinese wall where basically the Mongols were just coming in and coming out whenever they wanted. It is a great wall, so it's a very impressive monument, but perimeter security is maybe not a good idea. When your perimeter security is based in code, you might have these kind of situations that you really don't want to have all your eggs in one basket. So for security professionals, I invite you to think about the different layers where you have your protection. For developers, I invite you to think about security controls as things that can fail and will fail one day. Okay. Takeaways. There is three things that we covered today. There is a difference between the what and the how. When you have this difference, you can take the how and shift left whatever is the most annoying thing at the end of the chain and automate. And I can guarantee you that this is an investment that pays off. That comes to the second point. When you are in the rush of delivery, when you are in the rush of deadlines, sometimes you need to think about what is gonna slow you down, right? And these are all the things that are maybe manual, repetitive, at the end of the change, QA, UAT, etc., etc., etc. These might be also client interactions, right? That you want to shift left and make a way through to optimize your development. And finally, security controls are always implemented as code. They will fail. What is going to happen when they fail in your architecture, in your code bases? Do you have a plan B? And I think that's it. Thank you very much. I'm Santiago. I think that's my LinkedIn. But I'm a security guy, so you never know. Thanks.